So in this lesson, we're going to be solving proportions. Remember, proportions are just equivalent ratios, and you've already done those this year, but we called them earlier in the year equivalent fractions. I can apply my knowledge of equivalent rates, proportions, and cross products so that I can set up and solve real-world problems involving proportions. I will know I've got it when I score an 85% or better over this lesson. Hey, we're just going to do a little recap on what equivalent ratios are. We've talked about this for a bit now, and now we're just going to kind of review it. Remember, equivalent ratios are two or more ratios, which we also can think about like a fraction. Two or more ratios, we put them in fraction form a lot. Remember, ratios are just comparing numbers. Two or more ratios, fractions, with the same cross products. Okay, they have equal cross products. So what is a cross product? A cross product is when you have two fractions set up and you multiply across the equal sign to get a product in both directions. So if I multiply 6 times 50, I get 300. And then my other cross product, there's two of them here, 25 times 12. And if I multiply 25 times 12, I also get 300. So since these two fractions are set up, we can check to see if they are equal to each other, if they have the same value, by simply multiplying across those equal signs and getting their products. And if the products are the same, then we know the fractions are equal. They're equivalent. If they don't come out the same, then we know one fraction is either bigger or smaller than the other. So it's a way to compare fractions by simply doing what we call the cross product. So let's try the next one. If we multiply, get your calculators ready. You multiply 8 times 24 on your calculator. You got to do that on your calculator. Pause if you need to. You should have gotten 192. Then if we go in the other direction and we multiply 12 times 18, we get 216. As you can see, the cross products are not the same on this. So these two fractions are not equal. One is bigger or smaller than the other. So you could figure it out if you do the math on this one and you divide 8 by 12 to convert it to that decimal form. You're going to wind up getting 0.6 repeating. And then this one, when you do the math, you're going to wind up getting 0.75. So this fraction right here is smaller than this fraction right here. So this number came out smaller because they're not the same. There's a way it works. Okay, the next one is we're going to do 1,115 times 50. Punch it in your calculator, pause the video, and then do the same this way, 250 times 23. Go ahead and plug those in, and then turn the video back on to see if you got those products correct. So you should have gotten for this one 5,750. When you punched in 250 times 23, and you should have gotten 5,750 for this one as well. Because their cross products are the same, we know that this fraction has the same value as this fraction. Even though they don't look equal, they are equal. All right, they came out the same. Okay, so we're going to be dealing with the proportions. So when we looked at those examples before, the first fraction or proportion we set up, the first set of equivalent, I'm going to go back to that. This example right here where we did the cross products and they came out the same, and this example right here where we did it came out the same, these are called proportions because they're two fractions that are equal in value. This is set up as if it is a proportion, but they're not equal, so it's not considered a proportion. So that does bring us to this problem, and it says a proportion is an equation, okay? It's got that equal sign in it, right? It's an equation that states that two ratios are equal. Okay, so two equal fractions or two equal ratios. So here I set up a proportion This is the proportion when you put the two fractions with an equal sign in between, but I'm missing a value. So it says, hey, in these examples, determine the missing value to make this equal. What number is going to have to go here so these are actually equivalent fractions? And I want you to scale up to generate it. You might need to scale down. Okay, so in this first one, if you look at your numbers, you have the 2 in the bottom. So we're going to use these 2 to figure out how to scale this fraction. Well, I'm trying to figure out the top number of this fraction. So I look at that 20 and that 80, and I go, that I have to scale up. It went from a smaller number to a bigger number. It went from 20 to 80, so I have to scale up. And we say that it's by 4. By 4. The 4 comes into play because I know 20 times 4 is 80, or 80 divided by 20 is 4. So 4 is that magic number, and we need to scale up, so we multiply by it. Whatever you do to the bottom to keep it equivalent, right? Equivalent fractions, equivalent ratios, they're called proportions. We have to multiply that also by 4, and we find out that this missing value is 36. So 9/20ths is equivalent to 36/80ths. This is this fraction here in lowest terms, actually. We just scaled it up. Okay, this next one, it's x over 8 equals 18 over 24. So we have to decide what we're going to do. Well, when I look at this, I need to figure out this missing number. And when I look at the two numbers that line up in the bottom, it went smaller. So I know I need to scale this one down from a 24 to an 8. So I got to figure out what that magic number is. Scale it down by how much? Well, the fact families tell you 24 and 8, that magic number to either go up or down is 3. That's the missing piece of our little fact family here. And it's going to be a divide by 3. So we're going to divide by 3 to get that 8 to scale down. What I do to the bottom, I have to do to the top. So I'm going to also divide that by 3. And when I divide 18 by 3, I get 6. So I scaled it down and I get 6/8. Now that is the number that makes these two fractions or ratios equivalent, and that makes it a proportion, an equation with two equivalent ratios. Okay, this next one, we're going to try to scale up or down. So I'm going to look at what I have. I'm trying to find this number right here. So I'm going from this fraction to this fraction. And when I look, it's getting smaller. So I need to scale it down. I got to now figure out by how much. So I'm looking at the 28, I'm looking at the 14. If you need your calculators, use them, but hopefully you can see that we cut 28 in half. We divided it by 2. So what you do to the bottom, you got to do to the top. So we're going to scale this, sorry, I didn't put this, scale down by 3. This we're going to scale down by 2. We're going to put a divide in the bottom here, and we get 25 for our missing value. So 14 over 25 is the same as 28 over 50. Okay, there are going to be problems, and a lot of them in real world situations that are not that basic like the ones we just did where we could figure out what to scale up or scale down by. So we're going to learn a new procedure for finding a missing value in a ratio equivalent fraction setup that will allow you to find those more difficult values. This setup here is called solving proportions using cross products, which is that multiplying across the equal sign that we practiced that skill a little bit ago, and algebra, which we haven't done in a bit, so we're going to work on that algebra to help us get these values right here that are trickier. Because when I look at this and I try to decide if I'm going to scale up or scale down, that's easy to see because I'm going from this fraction that I'm given to this fraction right here. But when I look at the 32 and the 48, it's not real obvious to me what I need to scale it up by. I'm going to have to do a little bit of work, and it might be an ugly decimal, who knows. So we're just going to find a different way to approach these problems. So we're going to start off with just doing cross products. If this fraction equals this fraction, then I know that when I multiply these two things together, I'll get 32x. Still don't know what x is, but I'm going to just do cross products. And then when I circle and go this way, and I multiply 18 times 48, I get 864. You'll use your calculators for that. 18 times 48, give it to you this time, 864. And we just rearrange this proportion. This equation is just getting rearranged into a different format. And now it's just a multiplication problem. And we've studied these this year. We solved these algebraically, where we drew a line down the equal sign. Then we circled our variable. And we said, hey, we got to get x by itself. And it's a multiplication problem. So we got to do inverse operations on both sides of that equation. So if I'm multiplying 32 times x and I need to find x, I have to divide by 32 on both sides. And when I divide 32 by itself, I get 1x. When we throw into our calculators, 864 divided by 32, do that now. And when you threw that in, you should have gotten 27. And then 1 times x is just x. So let's quickly just kind of talk about that algebra again. When we have a multiplication equation and we're missing one of the factors, one of the parts, we have to divide to get that part. And in the algebra world, they do it on both sides to keep balance. And that's so that when this 32 will go away here when we divide it. And when it goes away, we're isolating x. And then on this side, we're getting the solution. So remember, when you're showing your algebra, isolate the variable, and get the solution on the other side. And this is required steps. You got to use what we learned earlier this year and continue to practice and apply it. Okay, so we're going to do this one right here, and it's 21 over 35 equals 36 over x. So I'm looking at it and I'm saying, yeah, to get from this fraction to this fraction, I have to scale up. I need to multiply by something, but I don't know what to multiply 21 by to get 36 quickly in my head. So very quickly, we can just do that process and it's going to work. It's going to work every time. 21x. We're rearranging this into a different way to view it. As opposed to fractions, we're getting these denominators gone. 35 times 36, you're going to pause the video and punch that into your calculator. And you should have gotten 1,260 there. And now you have this algebraic equation. The denominators of our fractions are gone. It's just straight up multiplication. When it turns into this, whoop, that's a terrible line. Try to draw a straight line, best you can there. Down your equal sign, circle that variable, because that's what we're isolating. You can see there's a 21. We want to isolate, we want to get it by itself. And over here, I need the answer. So I'm going to go divide both sides by that 21, keep balance, and then that cancels and you get 1x. And on the other side, dump that into your calculator, pause the video. And 60, you should have gotten 60 here. So x equals 60. So 21 over 35 is equal to 36 over 60. I'll throw that back up here so you can see how it looks. So that's basically how that works. Cross products every time for these when they're kind of tricky and you can't see what to multiply or divide by right off the top of your head or easily, just do the cross products and some algebra. Okay, so you're going to try this one on your own. Just do the first one, 15 over x equals 70 over 126. Study it up so you're looking at it going, yeah, am I scaling it up or down? And you should notice you're scaling down because the fraction you're given is 70 over 126 and the new fraction has a 15 on top. So when you're done, you should have a number that's less than 126. If you get a number bigger than 126, you've done something wrong. So use some number sense. Then do your cross products. And then do your division on both sides of the equation to show how you got the solution on one side and the variable on the other. Turn the video back on and you need to check your steps with mine because your work should look exactly like mine looks because that's what we're studying right here. You have to show me you understand these two pieces by the work you show here. If you've missed any steps, then you're not going to end up with that full credit. Okay, go ahead, pause the video, do the first example, and then turn it on to see how you did. Okay, so your first step, you should have gotten 70x equals 1,890. And then you should have divided both sides, circle that variable, line down the middle, divided both sides by 70, because that cancels this out and gives you that 1x. You're isolating. And on this side, it gives you the solution, 27. So it's 15 over 27. 15 over 27 equals 70 over 126. And I'm scaling down, so my 126 did shrink. So it worked out. Okay, now I want you to try the next one. X over 28 equals 36 over 48. So look at your problem. First thing, use some number sense. We're given this fraction, and we're trying to create this fraction, so we're scaling the 48 down. So our number, again, that we get for X should be smaller than this number right here, 36. So go ahead and do the cross products first, and then solve using algebra. Circle your variable, line down, divide on both sides, keep the balance. Then turn the video back on to see how you did. Okay, so you should have gotten on this one, the cross product, the first cross product is 48x. And the second cross product should have come out to 1008. And then you divide both sides by 48. And you get here, these cancel and give you this 1x. On this side, when you throw it in your calculator, you get 21, and x equals 21. So the fraction was 21 over 28 equals 36 over 48. And it makes sense. This did shrink down because we scaled it down as this also got smaller. So it makes sense. Okay, so that skill we just practiced is going to come in handy here for these word problems that involve rates and equivalent ratios. Remember, equivalent ratios are proportions. So we're going to set up proportions to solve these, and then we're going to use cross products and algebra to get the final answers. So we have to read it first, and we have to apply the knowledge we've been, apply what we've learned so far about rates and how we've been setting them up. So Jack surveyed his class about their favorite food. 15 students out of 25 students in his class said pizza is their favorite food. Based on this ratio, if there are 1,020 students in the school, how many would you expect to say pizza is their favorite food? Now we've used the double line diagrams and tables to set this up to try to get a feel, but we're not going to do that for this. We're going to try to lose those visuals and just apply what we learned from those about multiplying and dividing, scaling up, scaling down, and now cross products. So first thing, back to the basics, we need to find our units. So we have Jack surveyed a class about their favorite food. And then 15 out of 25 students said pizza was their favorite food. So that 15 represents the students that said pizza. So I'm going to put a P for pizza up here because I have two sets of students going on. It'll be a bit confusing. So 15 said pizza out of 20, there's your fraction bar, out of 25 students in the class that said, out of 25 students in the class. So I'm going to put down here, C for students in the class. So this is a little tricky because we have two sets of students, but there's a distinction. There's the ones that like the pizza to all of the students in the class. So I used P and C. The next thing I'm going to do is I'm going to put the quantities in, the numbers for those variables. So 15 represents the pizza people, and 25 represents those pizza people plus 10 kids that didn't say pizza was their favorite. All right, so I've got my setup. This is all handed to me in the problem. And then there's another number that's handed to me. It says based on this ratio, the 15 to 25 ratio, if there are 1,020 students in the school, that's all together. So maybe I shouldn't use C. That's probably a bad variable. I just decided that. When I read it, I'm like, ugh, this doesn't represent school, the C, but it represents a total. So pizza lovers over totals. So 15 over 25, and my total for the school is 1,020. So I have 1,020 students in the total school. How many of them would I expect to love pizza. That's their favorite. So we do our cross products. I like to circle them as I modeled in the other problems. Circle your cross products, help you, again, just stay organized. And when you do 25p, that's all you get. There's no number to multiply it by, so we just say 25p equals, and then you throw into your calculator that 15 times 1020. Comes out a big number, but we're using calculators, and even if we weren't, we could do it. It'd just take a little longer. We would set that up, and then we're going to circle our variable, draw a line down the equal sign, and I'm going to have you pause the video to solve this using your inverse operations, divide on both sides, and then clean it up to get the final solution. So pause the video, do the math, and then check your work to make sure you showed the algebra correctly on both sides and you got the correct solution. So when you did your cross products and we divide, so we ended up with that 25p equals 15,300, divide by 25 on both sides. You need to show it on both sides. And I did drop the 1p. I didn't write 1p here. That's okay. You can do that math in your head right here. 1 times p is p. So we can drop that middle step, I think. And then the 15,300 divided by 25 is 612. And then we put our units back on when we're done, because what we were trying to find, how many we would expect would say they love pizza. So it's 612 students chose pizza as their favorite. So that's the units back on. Okay, so that's the expectation. You're in your word problem, you're circling your units, identifying important information, and then you're setting up your abbreviated word form, and then you're setting up the proportion, and then you're solving it today using cross products and algebra. Even if you see another way to do it, we are practicing this skill. We've already practiced the other options for solving. This is a new skill, and that is the focus of the lesson. Okay, so our next problem, it's Jose is trying, they should have a little accent there. Jose is training for a marathon. He ran 6 miles in 33 minutes. If he maintains that speed, how long will it take him to run a marathon? Well, a marathon is 26.2 miles. So they're trying to figure that out based on this rate. If he continues at this rate, how long will it take him? So the rate, it contains the units. We're comparing miles to minutes. So he went out for a run and he ran. Since they both start with M, it's a little tricky. I'm going to do my abbreviated word form as distance to time, so I don't get confused when I'm putting my units on when I'm done. Okay, so we have distance to time. So the distance was 6 that they gave me. All this is handed to us over 33 minutes. And they're trying to find out time. We don't know this. And the distance that we're running now is 26.2 miles, that marathon. All right, so pause the video and do your cross products. Remember, we're going to do cross products first because our proportion is right here. And then once you get your cross products in place, do your algebra, inverse ops on both sides to isolate the variable and get the answer to the prompt. Then put your units back on and turn the video on to make sure you're all good with the required steps. Anything that's missing from your work or incorrect, you need to fix if that happens. If not, good job and keep plugging. So pause the video. All right, so you should have gotten 6t equals 864.6 from your cross products. And then once you have that, you got to isolate t. So I'm circling it, putting the line down the equal sign, divide on both sides by 6. The 6's cancel, making that 1t. And 1t is just t by itself, which is the goal. And on this side, 144.1 minutes. So I have a question for you. It's not in the notes here, so I'm going to prompt right now. I want to know about how many hours is this? You have 144.1 minutes. Do you know about how many hours that is? So pause the video, see if you can figure out about how many hours 144.1 minutes is. And then turn the video back on to see if you got it right. So you may have just figured it out on your own doing 144.1 divided by 60. A lot of kids will say, well, you just divide it by 60 because you know there are 60 minutes in an hour. That's a unit rate. You know that. And we're converting 144.1 minutes into hours. So some of you just intuitively know that's how you would figure that answer out. And if you did that, you should have gotten 2.4016 repeating hours on your calculator. And that's about 2.5 hours. It's a little less than that. But when you're running a marathon, you're not really timing yourself in minutes. You're timing yourself. A better unit of measure is probably for time is hours, because it just makes more sense than 144 minutes. You have a better idea of what that time frame is. But if you didn't know, you could have set up what we're doing in this unit. You could have set up a proportion using that unit rate. We know it's miles to hours, 60 to 1. You should know that just because you're in 6th grade and you know time. So that you've picked up over the years. And then you set up what you know, 144 minutes. That goes on top with your 60. And we're trying to find hours. So I put the variable there for hours. Then you do your cross products. 60 times h is 60h, and 1 times 144.1 is 144.1. And here's where that divide by 60 comes in. That some of you knew to do. So if you knew to do it, great. But here's where it happens in your algebra. Your algebra will also force you into that divide by 60 to get your final answer. So if there's problems you're unsure about, and setting up this proportion, if you're like, I'm not sure how to figure it out. I know it's 60 to 1, but I don't know, do I divide? Do I multiply? Do I add? Do I subtract? This proportion forces you into the right way to do it, which is to divide by 60. So jot this proportion down. Jot this down so you have a good way, because I could have asked you here, how long in hours would it take to run the marathon? Which means you would have had to figure out the minutes and then convert that over into hours anyway. So jot that down just so you have a sense on how to do like rates when it comes to time and converting those minutes into hours. It's a good example to have in your notes. Okay, so you're going to set this up on your own, but we're going to read through it together and make sure we circle the units and get off to a good start. So Jessica has a goal to earn at least $765 babysitting this summer. She made $255 this week and babysat for a total of 15 hours. At this rate, how many hours does she need to work to meet her goal? So Jessica has a goal of $765. So that's the least she'd like to make in this summer. But she made $255 this week babysitting for 15 hours. So my units that I'm circling, that's a good place to start. We're going to compare her money to her time and hours. So it's money over hours. That's where you always want to start, is with these abbreviated word forms and circling the units in there. Then you want to look at the question. We need to know how many hours. So we're going to be using H in our proportion. So you need to set this up with a proportion, 2 equivalent fractions. One of the fractions as ratios is given to you in the problem, and the other one you're only given part of it and your variable goes in for the other part. So once you get the ratio set up, turn the video back on to see if you have it set up correctly. Okay, so from the problem, we got $255 for 15 hours. So that's my first setup, money over hours. And then they told me, hey, we're trying to hit $765 in the dollars. So that goes on top because my unit of dollars is on top. And then it's saying, hey, how many hours will it take to make that money? So that's where my H is. So if you have that set up correctly, you're going to now go ahead and do your cross products and your algebra. We're using this method, even if you see another way. We're doing cross products and algebra to find H. So pause the video, set up your steps, and then turn the video back on to see if you found it correctly and showed all the algebra that's required. Okay, so you should have gotten, when you did your cross products, 255H equals 11,475. And to get H by itself, we divide both sides by 255. And you should have gotten H equals 45 hours. If you missed any of these steps or you have any incorrect values in the equation, you need to fix it now, review it, and make sure it makes sense before you move on. If you got it correct, kudos. Go on to the next example. Okay, so read this together and just get some thoughts down, and then we'll go from there to have you solve it yourself and see if you're getting the steps correct. Mrs. Coate was filling up an in-ground swimming pool. It took 20 minutes to fill 24 gallons of water. If her pool holds 18,000 gallons of water, how long will it take her to fill it up? So reading this through, I'm looking for the units, and I see it's 20 minutes, so minutes is one of our units. And to fill 24 gallons of water. So I'm going to put minutes to gallons. M and G are good variables, keep us straight. All right, so we've got our units here. Now you're going to set up the proportion. Remember, one of the equivalent rate, one of the rates is given to you in full in the problem, and the other is partially given to you. We are trying to find out how long. So we're trying to find the minutes to fill it up full. So set up your proportion, turn the video back on as soon as you get that done to see if you got the proportion set up correctly before you start solving. So you should have gotten 20 over 24. That was given to us in this problem, 20 to 24. It's right here, 20 to 24. And then your second ratio that you should set up is how many minutes, M, for 18,000 to fill up the pool. Well, the pool holds up to 18,000 gallons of water. So there's your total at the bottom. Okay, now you're going to do the cross products and the algebra to figure out what M is. So pause the video, show all that algebra to figure out M, and then turn the video back on to see if you did it correctly. All right, so we did the algebra there. We set up the cross products, 24M equals 36,000. Once you have that, you can divide both sides by 24 because the goal is to isolate M right here. And when you divide by 24, you get 1M, which gets that M by itself. And on this side, you get your answer, which takes 15,000 minutes. And Mrs. Coate's trying to figure out, well, how long is that? So what I want you to do is go to the next example, and we'll set that one up together, because it's kind of hard to understand how long 15,000 minutes actually is. And so we're going to convert that. We're going to convert that 15,000 minutes into hours. And that way she might have a better sense of how long this is going to take. So there are 60 minutes in 1 hour. You should know that, just common fact knowledge. If it took Mrs. Coate 15,000, which is what we just found in the last problem, if it took her 15,000 minutes to fill up her in-ground pool, how many hours is that? So we're going to have to figure out our units. Well, we've got minutes and hours here. And this is a unit rate, correct? Because it has a 1 in that second piece of our ratio, 60 in 1 hour. So, and we know it took her 15,000 minutes, and they want to know how many hours. So we have this proportion happening in this problem. So the first thing we're going to do is we're going to put M over H. And we're going to write that unit rate, 60 minutes to 1 hour. And they don't have to give you the 60 minutes to 1 hour. You should know that. So I could have just posed this as, hey, how long is it going to take her to fill up the 15,000? Or how many hours is it going to take her to fill up that pool if it took her 15,000 minutes? And I shouldn't have to tell you the 60 to 1, but I did in this problem. Okay? So the next thing is we know the minutes is 15,000. So we're going to set that 15,000 up, and we're trying to figure out how many hours that would be. So H. Okay, and then you're just going to pause the video, solve this using algebra to get how many hours that is. Turn the video back on when you're done to see how you did. Okay, so you should have found that the cross products were 60H equals 15,000. Divide both sides by that 60. And you should have gotten 250 hours because we solved for H there, 250 hours. So thinking about this, some of you may have known, I didn't need to go through all that, Ms. Vandenberg. I know it's 15,000 divided by 60. And that's great because you're applying this unit rate in that way. So That's great, but hopefully you showed the algebra because it was just required for this to show you here's where your division comes out of when you're doing your cross products. It's right here when you're solving for that variable h. So it definitely relates to the way you did it. It just may have been a little bit more time consuming and work to show, but it still applies. Okay, so now I would like to know, this is still kind of crazy, 250 hours. She's like, how long is this going to take? Like, that's a lot of hours. So we might need to even break this unit down into days. How many days will this take? So I want you to pause the video and I want you to figure out how many days 250 hours is, and then turn the video back on when you're done to see if you got it. Okay, to solve this problem, you need to know a unit rate. That would be the most helpful way to get to how many days this takes. So the unit rate that your brain needs to kind of tag into is that there's 24 hours, here's your unit, 24 hours in one day. So over here, I did a proportion to solve this problem, but if you knew there were 24 hours in a day, you might have just done this expression right here, 250 divided by 24. And that would work as well because you're using proportional thinking, okay? Because you're using this 24 unit rate in your problem. Over here, when you set it up as a proportion, if you're not sure, you start with what you know, 24 hours to 1 day. That's a rate, hours to days. We're comparing two different units. And then you set up what you know, 250, and we're trying to find D. So we took the cross product, 24D times 250, and that sets up so we can get to this right here that some of you know how to do, 24 divided by 24 on both sides. And there it is. When you divide this, you get your answer, 10.416 repeating days. That's about 10 and a half days. So sometimes when we're converting things, we're getting numbers that are hard to wrap our head around. It started at 15,000 minutes. Well, Ms. Coates, like, I'm not sure exactly how long that is. So she converted to hours, and she's looking at that going, that's still pretty crazy. So estimation, she could have said 240 hours is 10 days, just using estimation. That's an easy number to use, 240 instead of 250, because 24 goes into 240 even, using that 24 to 1 knowledge, okay? So it ends up about 10 and a half days when you break it down, and that makes the most sense. That's real easy to understand how long that is. So sometimes the units are not easy to interpret. So we just keep breaking it down if we know the rates to do that. So for this, I could have asked you from the very beginning, hey, it took her this many minutes to do her gallons, to put so many gallons in minutes. But I could have asked you the question at the very start that would say, how many days will this take? And you got to recognize that you got to convert from minutes to days. And that took this step right here to get into our hours. And then from there, we went to days. So you got to really watch and think about your answer. If it doesn't make sense, break it down some more from minutes to hours to days, so that you get a good sense of what that is. Okay. Okay, so that concludes our notes for this lesson. So you're going to go work on some practice problems and keep the notes handy in case you need to refer to them. Remember, the work that you are setting up is required as we did them in the notes today. You must circle the units. You must set up the abbreviated word form. Then you must set up your proportion. And then you must show your cross products and your algebra on both sides. And then put your unit back on when you're done. All of these things matter when we're doing these rate problems. They show that you understand the full process, and at the end of the day, when you're done with that problem, you know what you were expected to find because you put the units back on. You're keeping track of what you're doing. Good luck.